So Michael and good morning everyone. So today we are going to discuss about the enzyme immobilization technique. Okay, we're still in the enzyme chapter, by the way. So without any further ado, let's start. Now, enzyme technology. Okay, this one small chapter in the semester 1 STPM syllabus. All right. Now, in industrial processes, unstable enzymes are immobilized by bound the enzymes to a solid medium. Now, this solid medium, also known as inert medium. Okay. Now, advantages in industrial processes. Enzyme is more stable. Okay, because the enzyme ability to change shape is reduced. So as you know that you have what we have learned previously in this enzyme chapter, enzyme molecules they have their own kinetic energy. By having this kinetic energy, it causes these enzymes molecules to be mobilized. Okay. Now, when these enzymes are able to move freely, it's pretty difficult for us to control them. Okay. We need to say we want these enzymes to bind with the substrate. So it's a bit difficult. It'll be easier for us to control the enzyme, okay, if we make the enzymes to be immobilized. So when these enzymes are immobilized, easier for the substrate to find the enzyme. Thus, binding of enzyme to substrate is easier or facilitated. When that happens, the formation of enzyme substrate complex is higher. So one of the advantage, if the enzyme is being immobilized, right, in the industrial processes is the enzyme is more stable. Then the enzyme can be used readily or maybe reused as well. Enzyme is inert. Okay, so there will be no contamination on the reaction products and purification of product is not needed. Low cost operation. Then enzymes can be easily manipulated. And another one is reactions can be carried out at higher temperature and wider pH. Now the disadvantages, okay, of immobilize this enzyme. So the enzyme's active site may be covered by the inert matrix, which is the solid medium. Because the enzyme, we are trying to fix the enzyme, right? We are going to make the enzymes not be able to move freely. So in that process, the enzyme's active site might be covered with the inert matrix of the solid medium. So if this happens, this will reduce the number of enzyme substrate complex that is being formed. Now, the enzymes are immobilized, thus lowering the chances of collision between the substrate and enzymes. So this eventually reduces the number of enzyme substrate complex that is being formed. Now, let's proceed with the enzyme immobilization technique. Okay, so first we have the physical adsorption, right? Physical adsorption. This physical adsorption, also known as non-covalent physical adsorption. So what happens? These enzymes, like you can see here, okay, are physically being adsorbed or attached to the support material by weak bonds. This support material is the solid medium. Right? One example of this support medium is porous glass. So enzyme is being attached to the support material by weak bonds. Since the enzymes are being attached by weak bonds to the support material, this process is reversible. So we need to say the enzymes can be attached or detached. Next, we have covalent coupling. Okay, now in covalent coupling, okay, now in covalent coupling, Okay, so the enzymes are bound covalently, okay, to a matrix of cellulose or collagen as support. So meaning to say, um, in this diagram here, as you can see, okay, the enzyme is being covalently bound to the matrix of cellulose, and this matrix of cellulose function as solid support. Now, since the enzyme is being bound covalently, this process is irreversible. So meaning to say, you can't simply detach the enzyme from the matrix of cellulose. So simply, this is the enzyme, okay, that is being covalently bond with the matrix of cellulose, and this is very different if we compare with the physical adsorption, where this enzyme is being bound by weak bonds to the support material. Next, we have entrapment in gel. So the enzymes are being trapped within the matrix of gel. An example of gel is alginate, okay, which is also known as silica gel. So these are the enzymes, okay, being trapped in a matrix of gel. Or you can refer to this diagram here as well. This is the matrix, sorry, this is the gel matrix, and these are the enzymes, and this process is irreversible. Okay, so we'll recover 1, 2, 3. Now the fourth technique is entrapment in microcapsule. So meaning to say, the enzymes are being trapped in a semi permeable microcapsule. Okay, so the enzyme might be trapped in the semi-permeable membrane, or enzymes might be trapped in one semi-permeable uh, membrane of microcapsule. Okay, and then the fifth is cross-linking. So meaning to say, enzymes, as you can see from here, forms cross-link between enzyme molecules, and this is irreversible. Now again, Michelini, she came up with this mnemonic, how to remember all five enzyme immobilization technique. Okay, Andy enjoys eating chicken burger coleslaw. So Andy means adsorption, enjoy is encapsulation, then entrapment, covalent bonding, then cross-linking. So that's it for today. Okay, all right, bye.